Where we will be discussing about some case studies around the world. And I will be more than happy to moderate this afternoon. My name is Ayşegül Özbakır. I'm a full professor at City and Regional Planning Department of Yıldız Technical University in Istanbul, Turkey. And my research area is also on energy efficient lifestyles, basically on a larger scale at a city scale. But today we will be more focusing on the architectural scale, I guess, and our valuable presenters will provide some interesting case studies. And we would like to start with Dr. Carlos Jimenez Bescos. Hopefully I said correctly your name. His research areas are actually indoor air quality and energy monitoring, dealing with issues in health and well-being due to low energy approaches to construction, such as Passivhaus, and the application of data analytics, which is really that I'm very interested in to hear, with a mixed methods approach and to generate a deeper understanding in energy use, energy efficiency, and the impact on user behavior and policy. Before we continue, I would like to remind that this session is about an hour and a half time spot, and we will be devoting some 20 minutes for each presentation. And at the end of all of the 3 presentations, we will be able to answer your questions specifically addressed to our presenters or to myself as well. And I would like to leave the ground to Dr. Carlos Jimenez Bescos. Please, Dr.
Hi, thank you very much, and thank you for the invitation for the talk. So basically, I'm an assistant professor at the University of Nottingham, and this work is let me redo the screen. Okay, so that should work better, hopefully. And well, like I was saying, I'm an assistant professor in building services and environmental design. And what I'm going to be showing you is talking about passive house in different climates, looking at what are the challenges and what are the opportunities that we can apply due to vernacular architecture. So just to give an outline, we will talk about the different issues that could happen in different climates, what are the opportunities, why to focus on vernacular architecture, and I will talk about 3 projects that I work with in Iraq, in China, and Australia, and in Greece. So obviously this work is thanks to my students and a very good collaborator. So thank you to Bang, Binjan, and Nasia, and Dr. David Kroll in the University of Adelaide that we work together in UK and in Australia. So we understand that passive house has very well been developed in cold climate, in continental climates, and we all know about it, and we are very happy about how it works. But obviously now we are expanding more and more. We are looking into other climates. I mean, saying that in the United Kingdom we get some issues with overheating, even that we don't have that much of sunshine and heat. But suddenly, you know, we are moving to other places that are hot and humid, and there are different issues to deal with. But I think at least what we find is a massive problem for us in UK is 2 misconceptions that people think about when they talk about passive house. On the one hand is that they think that mechanical ventilation with heat recovery is basically taking over the whole year. And the other big problem that we have is talking about windows cannot be open. So when we go and see users and they complain about how hot it is and they cannot stand the heat inside, we said yes, but did you open the window? And they were told not to. I mean, this is the major problem that we have. When we get into summer, you are expected, and it has been designed by the passive house designer, that you are going to be making use of your windows. But we tend to forget that. So suddenly we are looking at that in our continental climates and UK climate. We already start to get problems. So obviously we're going to move to even hotter places. This is going to be much more of a challenge. So the opportunities is actually, we can start to apply some concepts of passive design, which is actually different to when we talk about passive house standards, not to be confused. And vernacular architecture actually grew up through that process, trying to apply more of a passive approach to actually cool down places. And the other aspect is that allow us to put the user and social aspect into the design. I always say to my students that buildings don't use energy, people use energy. And for us as designers, we can design the best building, but it's entirely up to the user how they're going to use it. And that's what we end up with quite a lot of problems. The other opportunity that we get is actually moving from the kind of modeling that we do in PHPP, where we are based on a monthly weather data and monthly energy, which, to be fair, is really accurate. But when we come into looking at issues of overheating, we need to have perhaps much more detail. And that's where using dynamic building energy simulation allow you to have an hourly modeling that we understand obviously is not for everybody, but it can open very good opportunities. So why to do vernacular architecture? Well, building has been around for thousands of years. We always had shelter, and they evolved through a process of trial and error. And this has been the way that a lot of the technologies actually we use nowadays. We learn from it. So there is quite an opportunity there to learn why things work and how we can apply it. The other thing, obviously, is that it's quite environmentally friendly because we tend to use passive approaches. I mean, air conditioning is very much available now. Perhaps, I can say, 10 or 15 years ago, certainly it wasn't the case in South Spain. And the other thing is that we get people to actually be able to enjoy better where they live because they have that cultural connection. So we start to talk quite a lot about what is a house and what is a home, and that kind of feeling that you can get. So there are obviously quite a lot of examples in the literature, and as well, courtyard houses are all across the world in different countries, and they tend to save energy. They tend to provide a different aspect that, more importantly, have a social value. So in terms of talking about Iraq, this is basically looking at Islamic architecture. We are looking at the concept that relate to the privacy, how a house open actually to the inside and not to the outside. The use of a central courtyard that is actually for lighting, for ventilation, keep the houses private. And obviously, we know that there are some issues in terms of having a courtyard and thinking about a passive house. A passive house is a very compact house where the form factor, and the form factor is the relation between the area, the surface that we have exposed, so basically the amount of wall and roof, comparison to the floor area that you have for the house, that will damage. If we have a courtyard, we create quite a lot of surfaces to be losing heat. Okay, so there's been already suggestions from El Sarai and Omar that perhaps moving from having a big courtyard into small courtyards to actually make it still work, but reducing the amount of heat that we are losing. And we have in the Islamic architecture the use of the E1, that is actually a way of sheltering from the sun, as well as having a buffer zone between the outside and the indoor spaces. So in this case, what we did is all the work was actually done through Design PH and PHPP, and we started to look at what kind of features of the Islamic architecture we could be actually implementing, and what kind of benefits we could be going. So we have a base model in which there was a small courtyard, and from that we start to input an E1 and to be able to see, okay, what is going to be the difference. At the moment, we can see there is only one building, and this is some of the factors as well that we were taking into account, because in reality, this is actually based on houses in the Kurdistan area where you only have one facade that is external. So everything else, you are basically surrounded. So we can see from the results that we were doing, we have a base model and we have 5 different cases. Obviously, we try to control what is the cooling load, and we try to control the frequency of overheating. We are trying to get our cooling load below the value of 15 for the Passivhaus standard, but as we can see, our overheatings were completely above the 10% that is expected. But we can see that you can actually have some progression. So we managed to get that to a point where getting some shading with the wall, working with that courtyard, we could actually reduce it to more closer values. Obviously, there is more work to be done and what is expected, but we are talking about initial stages. Probably things to look at here is increase the amount of courtyards. So instead of actually, even that was small, perhaps, having it in different places and see how we can create some kind of ventilation. Obviously, I mean, ventilation is a great thing, but if you got hot weather outside, there is nothing that is going to help you. So it's not a simple answer what you can get. In terms of looking at in China, we were looking at the Huizhou architecture. Well, the use of the vernacular architecture has already been used by Ouyang, not just for the culture, but actually looking at for the thermal capacity that you could be using. And what they were looking at as well is actually trying to implement some of the learning from the vernacular architecture into the retrofitting of this building. So, I mean, this is as well a big problem in Europe. We have a massive amount of buildings that need to be retrofitted, how we can make them and how we can make them to actually save energy and to be comfortable. So in this case, there were 4 factors that we were looking into, and those were about looking at the courtyards, looking at the floor to ceiling height. Probably this is more about the principle that if we look at the vernacular architecture, we tend to have very high ceilings, and the reason is because hot air is normally rising up. So that's the principle, to actually try to get the hot air to be at the top and try to be able to get them as well to go out. And the use of traditional materials, I mean, this has a lot of implications, and more importantly, from the point of view of embodied carbon. So you use it's a very sustainable way to actually try to use the materials that you are surrounded by. And the other thing is talking about the wall finishing colors that we use. I mean, and for example, from an area where we paint all the villages in white, and we always get the comment that they look beautiful, but it's not for being beautiful. It's actually to reflect the amount of solar gains that we normally get. So it's all small things that can be adding into saving energy. So in here, I will only show you some of the aspects of a comparison between a Model A that it will be a building according to the Chinese regulations that are at the moment, and a comparison to a building from vernacular architecture in the area. And to be honest, there weren't so many so many changes. There was obviously an increase in the solar gain because we have much more windows as well to be getting the solar gain inside. In terms of the losses that we were having through the walls and different parts of the facade, it was actually very similar, because in reality the way that the vernacular architecture was used with the materials allow us to have quite a low U value. So it performs quite well. Quite an interesting thing is actually the CO2. So we talk about Passivhaus, and we normally talk about, you know, how nice it is to actually live in there and how the health and well-being. Okay, but we need to measure it. We need to be able to actually say, okay, so what is actually happening inside? What is quite interesting is the vernacular architecture provide a lower concentration of CO2. I mean, nowadays is actually quite a lot involved in terms of talking about the indoor air quality because of COVID, and CO2 is actually increasing as a measure to actually check how is the internal space. So now we move to a different project. This is a Passivhaus in Greece, and this has been modeled using Energy Plus, what is a dynamic building energy simulation software. So this is based on hour to hour, but this brings a different approach. So I hope that most people will be familiar with the term of digital twin, but basically a digital twin is about, we create a model in a computer, and we need to think about that's how it's going to be working in reality. Well, as I was saying before, you build your building that hopefully is similar to what you model, but then you bring people. So the building is going to be used probably in a different way. So what we did in this case was actually really closely work with the people that were using the building and really model the building according to what they were, the way that they were living. And on top of that, we were very lucky that there is actually monitoring data for this building. So what we have here is on the right-hand side, a representation of the modeling in Energy Plus. On the left-hand side is a graph comparing the red orange line, what is the actual data hour by hour that was measured for the building, and the blue line that is the simulation that we have. Obviously, is under a 5%, what is really a good accuracy what we are getting. But this allows us to do a lot of things. Like, for example, we were thinking about, okay, so what about if we move it to other climates in Greece? So Greece have actually 4 different climates. Can we actually do it? And obviously, you know, this is what we were testing, and we can use exactly the same design. We didn't have to change anything in terms of, you know, bigger windows or smaller windows, or change the position. Nothing needed to be touched apart from having a thicker insulation in some areas that were colder. So this perhaps, you know, allow you to think about more of a mass production, a prefabrication way of actually delivering Passivhaus to everybody. I think I would like to put more emphasis on data monitoring, because this is the reality. A model is something that we build in a computer. We get sometimes rubbish in, rubbish out, but what we want to have is reliable data. And Peter Treguer always say that if you cannot measure it, well, if you don't measure it, you cannot improve it. So we need to have real data. So measure what is the temperature, the humidity is inside, the CO2, the energy use, and that will allow us to validate better our models and to generate much better decisions. So in this case, for example, it was about when you have a digital twin and you know it's working well, you can then start to say, okay, what about if I put it in other climate? What about if I change the insulation? What about if I change the windows? And then we can be sure that the results are quite accurate. And I think the final part that I would like to talk about is a little bit about a sociotechnical approach in Australia, where I work with David Kroll and some colleagues. We were looking at about trying to do an affordable social housing that could be deployed for the masses and using a SQL system. But it was about, I mean, if we go to Australia and we try to put a compact phone that will be perfect for the form factor, this is not going to work because they don't live like that. So we needed to actually implement how we can make a passive house design, that we can make a passive house, that we can get it approved, but at the same time that people want to live there. And I think that's quite the point. We need to be designing places for people to live, not places just to be efficient. So in this case, we come out with a concept of dividing the actual house in 3 different parts and incorporate the way that people live. So for example, in Australia is, well, the border, the barrier between indoor and outdoor is almost non-existent. So we try to be able to implement having the idea of almost having a courtyard there and see how we could be playing with ventilation to cool down the place, minimize the amount of air conditioning that was required, compartmentalizing as well in required areas. So for example, if you are going to be in one area, you don't need to be cooling the whole house, just cooling the areas where you're going to be. So different approaches that actually make it possible, and I'm trying to deliver it for everybody. I designed that will suit all people. So in conclusion, there are a lot of benefits looking at vernacular architecture. There are massive possibilities on the passive design. I think it's a good idea because we can actually get the culture, we can actually create places where people want to live and they will be much happier there. And I think it's important to understand when it's required to actually go into a dynamic building energy simulation. This is obviously not for everybody. But if you know that there's going to be issues with overheating, you are going to have to go there. And then it's when it's the time probably to contact other people. I mean, I hope this is a good example of what we tend to do in universities. So I would suggest, contact your universities and they'll be happy to work with you. And I think obviously digital twins are gonna be bigger and bigger and bigger all the time. So what we need is much more data that is available for everybody, and then we can work and generate much better models. Some references that hope that you can get from the presentation if you want to take a look to some of those papers. And thank you so much. Sorry, you are in mute. Your microphone is mute.
Can you hear me now?
Yeah.
Now it's okay?
Yeah, perfect.
Okay. Well, I don't know what happened. Well, anyways, I will repeat. So thanks for the presentation, and it was really great to hear the cases around the world. And I guess we'll have really great questions afterwards. So we'll speak more about that. So now I would like to switch to Micheel Wassouf. Now, you can hear me, right? Hello? Can you hear me?
Yes, I can hear. Yes.
Great, thank you. Okay. Micheel Wassouf is a pioneer architect in teaching passive house design strategies for hot climates and adapting passive houses and nearly zero energy buildings standard for Mediterranean and hot climates. Again, similar topics, I believe. And he participates as an international expert in several EU-funded projects for implementing energy efficiency and research in Mexican housing programs. So we would like to hear his presentation today. Please welcome. Yes.
Thank you. Thank you very much, Ayşegül. I will share my screen. So can you see the presentation, my presentation? Yes, I suppose, no?
Yes.
Okay.
Yes, we can.
So thank you very much. A warm merhaba to all the audience from Barcelona, from Spain. And I'm going to explain you a project we have, where we have done the design. It is a retrofit project in close to Barcelona. We had the luck to have the charge here from the municipality of the smaller city close to Barcelona, Viladecans, to do this retrofitting of an existing public school to an EnerFit standard, that is the Passivhaus variant for existing buildings. So we are here now tackling with retrofitting. So it's a little bit different, more difficult, I suppose, than Carlos said about the new construction. So for passive design solutions, it's more difficult, of course, because the design is already finished. We developed an energy audit of different public schools in this region close to Barcelona, and you can see here the main results. What is curious that all of these public schools in this Mediterranean climate have a quite high heating demand. You can see it's between 110 and 130 kilowatt hour per square meter a year. That was quite unexpected for us, because we have quite warm climate. So these buildings, they don't have an air conditioning. So really what the municipality wanted here is to decrease the heating demand of the building. I can show you here some photos of the building before the retrofit. This building has some severe constructional problems, also comfort complaints of the users, of the pupil, both in winter and in summertime. So we started before the retrofitting, before the design, we started with the analysis of this public school. We performed, for example, a blower door test, so to quantify the air infiltrations of this building. And as you see below on the right hand, the result of this blower door test was quite bad. So of course, this kind of building from the 70s in Spain has quite a bad performance concerning air tightness. The blower door test had 17 air change rate per hour. So for comparison, for a Passivhaus retrofit, this value can't be higher than 1 per hour. So it's like 17 times higher than the Passivhaus value. Also, we've analyzed the overall energy consumption of the building, and also it was quite curious to see that almost 75% of the overall energy consumption of this building was due to heating. So this is quite also an important issue for reducing CO2 emissions, also in this kind of climates where these public buildings don't have an air conditioning, and the most of the consumption of the energy is due to the heating demand. So our design strategies were quite simple, based on like the 5-6 Passivhaus pillars. We proposed to change the windows and overall insulation, controlling, improving the thermal bridges, also defining an air tightness level, and introducing mechanical ventilation. Also, we worked with natural ventilation at night in summertime. I will show you some photos quite fast, because I have a lot of analysis of monitoring. So I think it's more important to see the results of the real behavior of the building. Here you can see the U values of the windows before and after the retrofit. Also some thermal bridge calculations. Of course, in this kind of building, it's not so easy to get values similar to new building constructions, because you have in the retrofitting a lot of conditions where it is not always possible to get the perfect solutions for a perfect thermal envelope. Here you can see the mechanical ventilation system which we've proposed and which has been also installed at the end. It's a Passivhaus certified component. This was for us important, so to not only control the energy efficiency, but also a very high performance regarding the noise of this kind of buildings. Very quick, the design of the mechanical ventilation system of one floor of the building. Some photo from a classroom where you can see we introduced also textile ventilation ducts, so also to have some different and more friendly materials for these buildings. In this image, you can see the airtightness scheme. This is the pencil rule. We try always to have a continuous airtightness layer, which in this case hadn't been possible because on the ground floor there was no budget for also intervening in the ground floor. One of the big challenges and threats of this kind of projects is the limited budget for the retrofitting. So probably you have to schedule different retrofitting steps, like the step-by-step methodology. Maybe you know this. So here are also some photos from a detail of the window construction, some other details from thermal bridge calculations. We had also here introduced movable screen sun protection, which at the end for economic reasons couldn't be possible. So at the end, the building has been installed with fixed louvers with fixed sun protection elements. Here also one strategy was to change the light bulbs to introduce LED illumination to decrease also the electric consumption. And on this slide, you can see the calculated savings for the CO2 emissions, the electric consumption, and of course the main savings in the gas, because this was the heating boiler was driven or is driven by a gas boiler. The electricity consumption, as you see, theoretically was supposed to be the same after and before the retrofitting, because on the one hand, we had a mechanical ventilation, and on the other hand, we had also saving driven by the LED illumination. Here you can see the calculated repayment time, the amortization of this Passivhaus standard retrofitting has been calculated by 13 years compared to a normal retrofitting conform of the official legislation norm of the Spanish norm. So you can see also the costs of this retrofitting. At the end, it was like more or less 1 million euros for you to get an idea about this cost. I think per square meters, we've got at the end almost 300 euros per square meter. It's quite very low price, I think, for this kind of retrofitting, 3,000 square meters of floor space, floor surface. Here, one first result of the monitoring before the retrofitting. We monitored the building also before the retrofitting, and you can see that's a very interesting graph. You can see the blue lines, which is the 1 week, the outside temperatures, and you can see that this week, the temperatures dropped till about 7 degrees, and you can see how the interior temperature of this classroom almost perform the same as the exterior temperature. So this is very typical for a normal building constructed, let's say, in the last century or even in our century, which has a very bad performance regarding the temporal envelope, etc., and passive strategies. So after the retrofit, you can see also 1 week, one cold week in October, where also the temperatures dropped till 7 degrees more or less, and you can see the difference how the interior temperatures without the heating switched on. So without any active heating, the interior temperatures perform between 21, 22 degrees. Some photos from the building site. So I will now. I don't know, Ayşegül, you have to tell me the time because I'm not seeing now the chat box on my right hand. So
yes.
Just tell me.
You have more minutes actually.
How many?
You have approximately 12 more
Okay.
minutes.
Okay, so just tell me when.
I will warn you
minutes?
last 5
okay.
minutes.
So
yeah.
Now I have like this 12 minutes. I think that is enough to see the results of the monitoring. We wanted to know the CO2 performance of different classrooms. So as you might know, CO2 ppm concentration is like a very good way to know how is the real air quality, indoor air quality of our buildings. So this is the results before the retrofitting. You can see that these kind of buildings between January and March, these are the three on the left hand, have quite bad or high CO2 concentration, because this is the time over let's say for the orange bar, this is between 1,000 and 1,400 CO2. So the purple and the like turquoise bars are good quality, and then you have the orange, the blue, and the red bars, which are too high CO2 concentrations. And you can see very easily that starting from April, so this is the beginning of spring and summer, the pupil starts to open the windows, and therefore, of course, the CO2 concentration dropped down. And in these summer months, there are no problems, no issues about the CO2 concentration. So if we compare it with the values after the retrofit, I have to say that monitoring started in September of last year and unfortunately finished in March of this year due to COVID crisis. Of course, the school from March on has been empty, so we don't have, unfortunately, the values for the summertime. So you can see that the CO2 concentration is quite clearly better than when I go back, than the values before the retrofitting. We have an average of, I think, about 50 to 60% of the time below 800 ppm of CO2. It's certain that this building suffered some problems on commissioning. I mean, this is a overall problem in Spain, that the smaller municipalities, they don't have the maintenance departments prepared for this kind of, let's say, newer buildings. So the ventilation system in this retrofitting project suffered some operation mode changing, and actually till now there are still this first year of trying to improve the performance of the ventilation system due to just technical reasons actually. So therefore you can see that curiously at the first months of the performance, the CO2 values were quite very, very good, and then it decreased a little bit due to some technical problems of the installation of these machines. So going now to the temperatures, we can see before the retrofitting that the building performed quite bad. February, we registered almost 80% of the time with temperatures below the 20 degrees limits. And then also in May and June, there are a lot of hours during the lecture time of the school. Of course, all these values are during the lecture time of the school rooms. So June, we registered about 70% of the time above the comfort limits. This is better to see, I think, in this graph in winter time. Moreover, in February, we had very low temperatures. You can see that actually the temperatures dropped down till 12 degrees, which is quite very low. You have not to forget that we are here in this building about 1 kilometer from the coast, so it's real Mediterranean climate. Don't think about schools in the mountain in Spain or in Catalonia, which I think should be much worse than this building. And if we go to summertime, we have a quite good performance in April and May. In spring, I think these buildings perform quite well. The problem really is in wintertime and in real summertime. So the advantage here is that summertime, of course, the school is closed in July till begins of September. Anyway, the 3 weeks of June, we had temperatures reaching till 30 degrees inside
Last
of the
5 minutes.
Of course, 5 minutes. Okay, I should just to remind you that the building, all these buildings don't have any air conditioning systems for the summer. So if we go to the values after the retrofitting, we can see that the green bar is between 20 and 25 degrees of temperature. So the green bars are the inside of the comfort values. That's true that you can see there, I think, quite very well performing of the building. Of course, this was not surprisingly because we know that, of course, passive houses perform quite well in winter time. There has been some issues in September. When we go to this graph, which shows the development of the temperatures, linear development of the temperatures, we can see that, in fact, in September, this building had higher temperatures, reaching till 27 degrees, but they were still below, or let's say better than the performance before the retrofitting. Also, there are some issues concerning relative humidity, but this is a general problem in Mediterranean area, where the month of September is characterized by very high relative and absolute humidities, reaching till almost 80%. This is also due to this very high exterior temperature. I have to say that Passivhaus is based on the ISO 7730. So if we want to certify these kind of buildings, we have to implement an active cooling system also, because the PHPP calculations already showed us that the summer performance is not so well to be inside of the ISO 7730 norm. So active cooling measurements is necessary for this kind of building to get really to an optimum of comfort behavior. So the last slides are concerning the energy consumption. This is the electric consumption in the typical months of February. So we see that actually we have a light increase of the electric consumption. This is due, as I said before, to the mechanical ventilation. So therefore, it's very important to install very high performance mechanical ventilation. Therefore, we normally tend to install a Passivhaus certified machine, where we know that the performance is quite very high. The interesting slide is this one: the gas consumption of the building. We have two buildings. We have the retrofitted building, and then we have a smaller kindergarten building, which is the dark blue parts of these graphs is the kindergarten. Then we have the kitchen, and we have also losses of the heat distribution. And you can see the 4 years before the retrofitting, we have about, let's say this is 200,000 kilowatt hours total consumption per year. And you can see clearly after the retrofitting, this is the last two right bars, the energy saving. And if you look onto on the right hand on the numbers, So we have registered like about 5,000 kilowatt hours of real energy consumption. You can see the photo. These are the real consumption of the gas boiler for this main retrofitted building. So it's about 5,000 kilowatt hours, more or less what a normal family uses for in Spain for heating a building with gas. So this building, which has about almost 500 people, now is consuming like one family household. So I think this is quite a very good result. And the main concern actually of the municipality here of Viladecans has been to reduce the CO2 emissions of this building. So I think this could be concluded with the monitoring. The last slide is the resume of the monitoring. On the right hand, the CO2 concentration. We can see that before retrofitting, we had high quality indoor air quality 41%, and then a bad air quality, that means higher than 1,500 ppm of CO2, 23%. And after the retrofitting, you can see that this 23% has been decreased till 1%. So in the overall comparison, it's clearly better the indoor air quality of the building. And on the right hand, we can see the temperature, registered temperatures before the retrofitting. We had about 20% of the time lower than 20 degrees and 24% higher than 25 degrees. And if you see now the results after the retrofitting, we have now 2% of the time lower than 20% and 4% of the time higher than 25%. Of course, this is the last slide. I'm finishing now. Of course, we are continuing with the monitoring, and hopefully next year having the opportunity also to analyze the 3 months between, let's say April till June. So to understand also better the behavior of the building, not only in winter time, but also in summertime. Thank you very much. And back to you, Ayşegül.
Thank you, Wassouf. It was really great to speak with the numbers, actually. And I have some questions later on. Okay. So now we're switching to Bachir Nebia, I guess. Hello, Bachir. Bachir Nebia is an architect. He's also a development manager and works, I guess, for more than 10 years in London, if I'm not wrong, at Roberts and Treguer company, finally, his destination. Now he will make a presentation on a case study, Blaker Road case study in London, where he will be able to discuss Passivhaus standards in London. Please, Bachir.
That's right. So I'll just share my screen and we can start the presentation. Can you see it?
Yes, we can see.
Yeah, all good?
Mm-hmm.
Perfect.
Yep.
Great stuff. So I'm just going to present Blaker Road, which is a scheme that has been designed to Passivhaus standard in London. And I'm going to be presenting it from an architectural point of view, but mainly for an architect that works for the clients. So we are the developer, we're the client on this project. So we've designed it and we've built it ourselves and we sold it. So I'm gonna firstly talk about the site context, the design approach briefly, the challenges of the design and building a passive house, and mainly from a developer perspective and an architect perspective. And that is something that is not usually covered when we talk about passive houses. So what is the challenges for a client if they wanted to deliver a passive house and sell it on an open market? And finally, we'll talk about post-occupation occupation evaluation, just to see how the project is performing at the moment. So that's the site as it was previously. So it's a very challenging site because it's an island. It's a man-made island around two rivers, and that is the old log keeper's house. So there was someone living there taking care of the logs and making sure they are maintained. So we bought the site back in 2014, and we went through the planning process and just the design process, and really understanding how we can do something there in such a small site and in very challenging sites with very limited access. So you can see here a few pictures of the site as it was previously. You have the house in the middle, and you have a small bridge crossing the man-made island. So the site is very rich in history. I'm not gonna spend a long time on this, but hopefully we'll give you a little bit of background of why we've designed the current buildings the way they are. So the island's been there for a very long time. It changed a few times, but there is a house that was there in the late 18th century, and there was someone called Luke Howard that was living there. He was a famous scientist, and he's actually the one that named the clouds. So he was studying clouds, and he was studying climate as well. And he's the one that gave the different names of the different clouds that we actually know now. So we started trying to find some inspirations from that house and see how we can use that story in our site. Also, the surrounding areas are very industrial. Stratford is used to be a very industrial site. So there's a lot of warehouses around, docks, a lot of rivers, and we also try to include that in our design. So just as like an overview of how we started the design, so we kept that house that is in the middle, and we tried to reinstate the Howard's house and tried to put also a warehouse on the other side. So you can see it's two houses that have been built to passive house, one retrofit, and a block of 5 flats. And from there, we just started really working on the passive house design, understanding what is the daylight, what is the impact of the climate there, what is the initial U values that we need to target, and really working with the PHPP and see at early design stages before planning whether it's going to be feasible or not. So that's how we hoped it's going to look, and that was at planning stage, and we then took it forward. So once we got planning, I think like the main challenge for a developer is really cost and being able to make money at the end of the job. So one of the main challenges for a developer is, especially at early design stages, is really understanding the design of the cost. What is the cost of the design and the cash flow? So that's all you have at the bottom, all the REBA stages. And stage 3, that's where usually you apply for planning, you submit planning, and you get it before you build it. So anything that is spent before that, it's a cost at risk. So anything that you spend before planning is a cost at risk. So you can see that to deliver a passive house, it's about 20% more at early stages in terms of design, because you need a passive house consultant, because you need more time in daylighting, because you need a specific advice, and you need to run early PHPP models to make sure you can actually deliver it before you commit to it. So any cost before stage 3, it's at risk. So if they don't get planning, they've actually spent 20% more on just design cost, just to submit planning. So that is a very big challenge for cash flow, and also extra risk for developers. We move on to the design, post-planning. So I think and I will limit it today to the cladding, because I think the cladding was the most challenging one. So just as summarizing what's the basis and what's the main elements of the cladding in terms of Passivhaus. So we have the weather barrier, the insulation, the structure, and the air barrier. And usually we go from outside to inside, and we started looking at each one of them and see what is the best material that we use and what is the best way of designing the cladding. So we started with the superstructure, because that's something that we were keen on. We were also very well aware of the carbon emission of our building, and we were trying to find something that could sequestrate actually carbon in our superstructure. So we started with CLT, because CLT is becoming available in the market. It's easy to use. For our sites, it was quite good because we were building on an island, so we needed to build light. CLT is about 40% lighter than concrete structures. It's 3 times quicker. There is a big amount of carbon storage, and the big advantage is that it's a superstructure that is airtight. So once you've built actually the CLT structure, you've already have a structure that is kind of airtight that will help you a lot achieve the Passivhaus targets. One of the downsides is that it's about 20% more expensive than concrete, but you kind of win that in the time of erection of the superstructure, and it needs an earlier design coordination. Like about 2-3 months before the erection of the superstructure, you need to be done with your design to send it to a factory somewhere in Austria or Germany, and you get your CLT shipped back 2 months later for the erection. So that's something to bear in mind with CLT. I think the second one, that's a few pictures of the start of erection of the CLT. And you can see the 2 houses. We actually erected the 2 houses in 3 weeks. So when you compare it to concrete, that's quite, you actually win a lot of time in construction. The second challenge is obviously what is going outside of that structure. And London is very famous for its bricks, and because it was a site that had a lot of heritage background to it, it was part of the LLDC and post Olympics master planning. So there was a lot of restrictions, and we had to go with bricks. I mean, we love bricks anyway, but it's not great in terms of carbon emissions. But so we were trying to find ways of making it work with bricks. So we went from bricks to brick slips, and that's because it's 60% lighter. It looks the same, and it's actually the same thing. It improves the thermal performance because it gives you more space to add extra insulation at the back of them. However, it needs training. It needs training, especially for the guys on site. And there is a lot of parameters to take in consideration in terms of thermal bridges, because it needs a lot of fixings back to the structure. So that's just a small 3D modelization of how the brick slips are fixed back to the structure, and that's some samples of the bricks that we've used. So talking about the overall performance of that cladding, I think one of the biggest challenges is, once you know what you're going to use, you know the value that you're targeting, is understanding okay, now where I'm going to put my insulation, where I'm going to put my air tightness layer, and most importantly, how I'm going to control the condensation with the thermal bridges that I'm going to have, and making sure that I am actually delivering the design intent that we wanted from the beginning. So we looked at different options, and we've run some thermal bridges analysis, and the most important is understanding the dew point for the condensation. So we've run few examples, and few of them show condensation inside the cladding, and that's a big challenge, especially in the UK, due to the cold climate and sometimes humid climate. Condensation is a big issue, and you need to make sure that you design out any risk of condensation, especially on a timber cladding, because we know if we have some interstitial condensation between the insulation and the cladding, then that can affect the structure. So we've run a few options, and I'm just flagging it there because it's something that is very important to kind of design from the beginning and make sure you get it right. You also have few challenges in terms of condensation. So we had an area that was cantilevered, and we had to introduce a few steel columns and beams. Steel is very cold material, and we had to design, we had to insulate it, but we had very limited space. So we had to introduce some aerogel insulation that is highly performant and could deal with the thermal bridges around the steel and make sure there is no condensation and very limited thermal bridges. So just a quick summary on this first part, just on the lesson learned. So on a passive house, usually you have a more expensive design team. Passive house consultants and certifiers are required, and they are very useful. Early and more thorough design coordination required. So you need to start designing things earlier and very precisely. And the last one is really the devil is in the detail, especially with condensation and thermal bridges. Like usually from a design process perspective, you don't get to that detail at the beginning and people are not used to it. So you have to push the design team to get to that level of detail early stage to make sure you're covering that. Another challenge that I wanted to cover today is the cost against the value. And so what is the cost of delivering things and what is the value at the end? So from a developer perspective, to build a passive house, you usually need 10 to 15% on top of the usual construction cost. So you're actually spending 15% more construction cost to deliver a passive house. But the reality is that the market does not pay for that 15%. So at the end of the day, when you're going to sell the house or the flat, you're not going to sell it higher than the market value. Or if you're really lucky, you're going to sell it for like 3 to 5% higher. So you're not going to make that money back. So you're going to cut from your margin. And that's obviously not acceptable for a lot of developers. We've done it because we believe in it. But I think we also had to be smart in other ways to save cost and make sure we still have our margins. So how we've done that, and that's very frustrating, especially for architects, is finding cost savings. So anything that is not related to passive house, so all the packages that are not passive house, we needed to be smart in design. We needed to cut cost and deliver something that still looks beautiful but is cheaper. So we've targeted the kitchens, the bathrooms, the flooring, staircases, lifts, joinery, internals and decorations. All those packages needed to be cheaper to make up for that extra 10%. So you can see here a few pictures.
Last 5 minutes.
Yeah, there's a few pictures of how it looks inside. So you can see that all the internals are exposed CLT, so that saves us cost. The flooring is marmoleum, which is a natural product, but it's also cheaper and easier to install. The kitchens are very simple but well designed, cheaper tiles, very simple design where we can save cost there, and same way for the bathrooms as well. So that's few examples that we had to do. We had to design them right, but with cheaper cost. So in terms of construction, and I'm going to focus just on few points. So that's few pictures of the site during construction. And I think the biggest challenge is the workmanship. Builders are not used to Passivhaus, and people around you, all the different trades, are not used to building Passivhaus, not used to giving the care that it needs to. And I'm mainly going to focus on airtightness, because that was one of the biggest challenges, especially on the block of flats. So during the airtightness test, you can discover things like tapes over brackets of the windows, like even though the window installers, they were Passivhaus certified, they can still make mistakes, and that can make you not achieve your airtightness levels. You have like cables going through gaps on the window tapes, brackets again, insulation over pipes. They're very small details, but at a Passivhaus scale, they're actually big mistakes, and people make them all the time. So on the lesson learned on this part is really lack of training. The industry lacks a lot of training in terms of building Passivhaus. There is very limited understanding of the Passivhaus requirements when you come to actually building it on site. Airtightness champion on site is a must. Like, you need to have someone that is on top of the airtightness throughout the whole process. You need to have an experienced main contractor, and you need to have very, very, very tight cost control. So that's how it looks now. That's the project finished. You can see on the right the block of flats, on the left the two houses, and the middle the refurbished house. So that's the post-occupation evaluation. So we've done it for 2 years now. And you can see the black line is really the Passivhaus requirements. So you can see during the first year between our PHPP model and the first year monitoring, there is a difference, and the first year is always a bit challenging, because you have people that just moved in, don't know how to work with it, and also, for example, in flat 2, where you can see it's very low, it doesn't mean that it's performing well, but it's just the flat was not entirely occupied during the year, so people were not there, so that's why it's quite low. But for all the flats and houses that are on top of the 15 kilowatt hours, we need to have a look at them. So what is the problem then, and how we can fix it? So we've managed to kind of fix it, and we dropped the values down. So all of them are below the Passivhaus requirements, which is good news, apart from 2 flats, and we will have a look at why. So the flat 4 and flat 5, they're on the top, and maybe some of you guessed why, but it's a design issue, and it comes to an overheating problem. They're highly glazed, and yeah, they're the 2 flats that kind of overheat a lot in the summer, and people tend to use more, or use a lot more the mechanical ventilation, especially at night. So from a POE perspective, and trying to close that performance gap, I think post-construction, what is very important to have a look at and try to rectify during the first year is airtightness defects, because there is always defect on the airtightness. MVHR control and adjustments, especially on hot water and heating. So there is always few adjustments that you have to do in how the MVHR works and how it's controlled. The doors and windows leakage. So I think after the settlement of the building and during the first year, there is always leakage somewhere on the doors and windows, around the seals, around the frames, that you have to go back to and make sure they're all sealed. The occupants and the building users, it does take time sometimes for them to understand how it works, especially if they're not familiar with Passivhaus scheme, how they use the MVHR, how they use the heat pump, whether they open, close the window, they have a small radiator, whether they turn it on, not off. So it's a learning curve, and it usually takes them 1 to 2 years to understand. And also trying to understand from your design mistakes. So really learning from your mistakes, what went wrong at the beginning. Is the PHPP enough? Do you have to do a dynamic simulation, especially for overheating and so on? And yeah, I think I'll keep it to that. And thank you very much. And I'll welcome any questions that you have. Thanks.
Thank you, Bachir. I think we now concluded with our presentations, and as far as I'm informed, there are no public questions right now. So just to make a fruitful conclusion and to open up a little bit, I would like to start a discussion and some questions to each of our available presenters. So to start with Dr. Bescos, and thank you very much, by the way, because I believe the power of listening to different case studies around the world actually is a great value. So thanks again for providing such a comparison actually. And I was wondering about the Islamic architecture in terms of passive house design, your experiences among such case studies. Did you have a chance to compare with like a Spanish case study where the climate conditions are similar, the courtyard design principles are similar, but not in terms of cultural lifestyle, which makes a difference, I believe, but still in terms of the design principles, they're very similar to each other, some even Mediterranean cases too. So what do you think about the lifestyle effects on the passive house design when you compare such similar design versus their cultural effects?
Hi. Well, unfortunately, I haven't been able to do such a study, but I think it's one of the points that we would like to move into. I think it's actually the amount of courtyards around the world is amazing, and obviously in South Spain we have a lot of Islamic architecture, a great heritage that we have moved, and we have, like you say, adapted actually quite a bit. So. I think what we find as well in many different aspects is that it evolves according to the people, and I think from seeing the fact of changes that we need to do on educating people that they are still going to have that kind of social aspect of the courtyard, but we're going to have to make it more passive ready. Or let's put it that way. But I think the more people are bring to the knowledge on how to use it, it will be better. I think it's been great to hear the other presenters, and I think Bachir touched something quite important. Is from the point of view of how do you sell it later? People will buy what they are used to. So it's as well a bit of, let's start to get people to really understand why would you spend a little bit more money, and why would you maybe, still have your social culture, but start to make little adjustments. Enjoy. So, but yeah, definitely I would love to do some more work in Spain. I tend to do a lot of work around the world, apart from my encounter.
Well, yeah, actually it will be very beneficial for all of us. Thank you. A similar but a different approach. My question to Micheel Wassouf again. When speaking of the school buildings, there are lots of different styles and cases. Of course, when it comes to the primary school, the users are kids, and their behavior is completely different than our university guys, as we may all familiar with. So what do you think about the role of users might affect the passive house efficiency? And did you have a chance also to work with different school types? Are there any differences that you have observed speaking with data analytics especially? I was wondering. Of course, the scale and everything affects, but especially the type of the users. For instance, your statistics usually make some comparison on the teaching hours. So before teaching, while teaching, I guess, the efficiency of the energy use. So it might change maybe when it comes to the university, to the kids' school. So what do you think about these differences at all?
Yeah, we didn't have any experience with other kind of schools in Spain, unfortunately, but we had some, of course, a big issue was the behavior of the users of these schools. So we had a lot of sessions for explaining the project to the teachers. And in fact, we based our strategy in the design phase in summer. We based it on opening the windows at night time, and at the end, this ended up to be too optimistic because, or too idealistic because this didn't work quite well in the operation of the building in summer, because nobody or the person who was in charge of the maintenance of the building really didn't want to open the windows at night time. So we had therefore to change our strategy and to change the operation mode of the ventilation system. So now, hopefully, it's now still there are some problems, because I've already stated that the municipalities, these smaller municipalities, they are not prepared to this kind of project yet. So we have to change the control of the ventilation system so it can also work at nighttime and make night ventilation by means of mechanical ventilation. So, of course, one lessons learned from this project is being in very close touch with the users, also in the design phase, so to explain them your strategies and to explain them the design of the building, and so not to have some problems after the construction with the real behavior of these.
Well, it reminds me actually of one of our projects results. It's about an energy efficient lifestyle readiness levels. So it was again the same problem that we have observed. No matter what the design says and whether there is a perfect solution, still you need to provide some readiness for the energy efficient lifestyle, depending on the culture and all different groups, economically and socially also. So I extremely believe in this as well. Well, thank you. We will have another question to Carlos, but before I will continue with Bashir and then again to Carlos. Okay, well, Bashir, thank you very much. And I was very interested in this kind of presentation due to its heritage site renewal and a new construction as well. Which is also a very big problem in Turkey, especially in Istanbul, in all historical cities. As you may know, Turkey is a very historical country. So I was wondering about the cost issue that you have mentioned a lot. One of the most challenging issues, I guess. So among the construction costs, which item do you think is the most tricky, the challenging part? Because you've mentioned, is, if I'm not wrong, the CLT has arrived from Germany or something like that, you mentioned. So it's a broad construction material. So when speaking of buying or receiving that kind of a material from another country also increases the carbon dioxide emissions, as we all know, the green building concept, but still you preferred that one. So what do you think about these cost benefit, and also the other side of the coin, which tells us please use the local material and so on? So how do you
It's a very good question. I think so. So there is a cost and there is a carbon discussion here. I think from a cost perspective, it's like for our project, the CLT was cheaper than if we would have built it in concrete. And that's related to the site as well. Like if we would have built in concrete, then the building would have ended up probably heavier, which means deeper piling and a more expensive below ground structure as well. So I think hopefully that answers the question on cost. From a material perspective, the UK is a big importer of construction materials. There isn't that much timber in the UK, and I think there isn't big CRT factories in the UK. There is CRT factories, but not as good as the Austrian and the German CRT factories. I take your point on the carbon. I wish we had a CRT factory just around the corner and we would have used it, or maybe we would have just changed the way we built. But we made the decision to work with CLT at a very early stage. We've tried to do a carbon assessment of the whole building to understand whether the amount of carbon sequestrated on that superstructure will cover the extra bits of pieces that you'll have to spend to make it a passive house. Because there's things like just the fact of like bringing that passive house back from Austria to Germany, you'll be emitting extra carbon, but you'll have to do it anyway with any other material. So it's very hard thing to measure because you don't have all the data, unfortunately. But yeah, hope that answers your question.
Yeah, thank you. Well, we received one final question. Actually, I will try to read. The neo-vernacular concept, to Carlos, by the way. The neo-vernacular concept in one building does not mean using the entire technological approach to nearly zero building, because it returns to the existing climate and environmental conditions. Do you agree with this idea?
Well, pretty much.
I could not understand very well, but
yeah, I very much agree. I mean, I think what it can clear for me. I mean, I'm a building service engineer, but I believe the less technology we use, the better people understand it, how to use the buildings, and the more energy we save. So even that, obviously, I'm a very good believer of passive house. I still believe even more that, you know, we have something that can work passive is far better. So that's
thank you.
Thank you.
Okay, any questions among us, by the way? Any presenters question to another presenter?
Yeah. I might have a question for Carlos, actually.
Please go ahead.
Because I'm a big fan of courtyards. I come from a North African country, and I'm a big fan of courtyards. So, because I've spent a lot of time trying to understand how we can actually make a house work at passive house standards, or doesn't have to be passive house, but a very low energy standard with a courtyard. So I was just wondering, because you've mentioned one of the biggest issues that is the surface area and the form of the building. And one of the biggest principles of passive house is compactness. I was just wondering whether there is like a flexible way of like creating a courtyard, but keeping the house still flexible and compact. So if we had like a roof that actually opens up in a summer or a different climate or different weather conditions, that would change it from like an open courtyard to a compact house. And whether you had to look at that before, or if you've seen a case study or someone that's done it before, or maybe simulated something like this.
Well, I think that sounds like a really great project, to be honest. But yeah, I mean, I think that's the kind of thing it could work very nicely. That, you know, it's like a hybrid between having that the compact house in winter and suddenly you open it up. And yeah, I mean, I think, you know, this is why it's important, and the power that the simulation can actually give you. And so I'll be really interested, obviously, after this anyway, to carry on in contact, and we can look at this kind of thing. I think the idea as well of trying to integrate the smaller courtyards, but so that there won't be the same use from the user point of view, but it's more like having little spaces where we can actually increase that ventilation and the lighting coming in. That's as well an idea that we are thinking about testing and how it could work. But I think the reality is that you want something that people sell. I think that was quite an interesting point and from your presentation. And I think the other thing is that we need to get people to realize that, you know, you want a better house. It's not just for the energy, it's actually for the comfort. It's actually because it become a better place to live. And I'm hoping that in years to come, they will get to the point that you were talking about, that, you know, they will be happy to actually say, okay, I'm gonna pay a little bit more, but I'm actually paying for this. What, you know, people who has been in passive houses and designing them, we know it's there. We just require the market to realize that that's the case. That's, I think, the challenge for all of us is to actually, how do you get that market to realize that it's worth it to go the extra mile?
I think, yeah, I hope that day will come. I think in a challenging market like in the UK, unfortunately, a lot of people cannot afford, and it's about their availability of cash and how much on their mortgage. So if they have a limit, then they will try to get as big as possible, as beautiful as possible. Unfortunately, not always as low energy as possible, because the operation cost, it's a problem for later, where the cost for buying the house is the problem for now to solve. But I think that would be driven by, hopefully, policies from the government.
I mean, there are in Spain some multi-residential developers, like in Zaragoza, who are doing passive houses in a big scale, and they have quite a lot of success, and they argue moreover with the comfort of these houses, and with doing a very well marketing strategy. I think it's quite reasonable now to construct more passive houses also in the Mediterranean area. So they manage to, they have so much benefits, margins in their operations. So if they are really keen, they can offer passive houses at reasonable prices in multi-residential blocks, and sell them quite very well. At least this is now the first experiences in Spain. No? This is on the private sector. On the other hand, the public sector needs, of course, politicians who are aware about the ecological problems and threats, and offer policies and start themselves also toward passive houses. And this is, if you look on Navarra, which is a region in central northern Spain, they only do passive houses in multi-residential sector. And I think, of course, the threat is the overcost is, as you mentioned, Bachir, about 10 to 20%, but also doing each time more passive houses, and the overcost, like happened in Austria or in Germany, decreases now. If you see in Germany, we have overcost less than 5%. So it's quite, I think, the right way to do also for the Turkish audience. I think this is the only way to go to a better and sustainable future.
Thank you all.
If I may, sorry, I have a question for Ayşegül.
Sure.
But first, I think it's because there are some difference between there are some difference between the UK market and the Spanish market. In terms that the UK market is very dynamic, and to be honest, we change house. I don't remember what was the average, but something like 6-7 years you will be moving house. Over your whole life, you probably are in 5-6 houses easily. Well, for example, in Spain, is more about you spend more time. So when you actually talk to people, they actually say, yeah, I'm not sure about investing more because, I will be moving somewhere else. So I'm not going to get the benefit. And that's part of the problem that we have. So my question would be to actually in Turkey, how is the perception of a private house? Is something that is a family place that you live for longer, or is just more transitional like the UK market?
Well, unfortunately, house ownership actually in Turkey is not that extremely high. I'm not quite sure about recent statistics right now, but it was like 70% of the population were renters. So unfortunately, due to the economic crisis and due to the budget allocation for a typical Turkish family is extremely getting problematic area in Turkey right now. Most of the vulnerable populations, underrepresented groups, etc., generally speaking, they cannot own even a decent place to live. So where it's for renting a cheap place, even they have to change a very yearly basis or twice a year sometimes to another place. So that makes very difficult policy making in order to invest on the sustainable design actually. For the other hand, the ownership, when it comes to the ownership, people usually invest on more than one house just to have additional income where they cannot have from another sector for sure. So therefore, they do not actually too much pay attention on the quality of the place where they live or where their renters live. So it's quite tricky. However, with the recent COVID events, around the country, we all have, I think, realized the importance of the quality versus quantity. So I have started hearing about voices on the importance of the parks and even the recreational areas, a proportionally designed parcel. So these things are getting very awareness increasing among the society. But still, it's not that actually at the high level, I can say. And speaking of changing a place, it was before, like when a typical Turkish family would locate, they would own a house, it would be the one that they would live forever. So they wouldn't change. However, due to the urban transformation projects rapidly going on in Turkey, it now stopped actually, but it was in the last 10 years, it was an extremely bomb in Turkey. But now people change just wherever is cheap for them. So that makes, interesting story. So coming up to our final conclusions, I would like to thank all of you for being here, and thank you for all organizers, international and national board members, all the administrative and technical staff. And I would like to say one small thing about the value of these kind of events, even though they're online. It's really great to be a community having same interests and issues coming up on the same agenda, and to remind that the European Union Commission's new agenda on the Green Deal, I believe the companies, private companies, SMEs, universities, the NGOs can come together throughout these events to make some applications on these grants, where we can find some new solutions, innovative ideas, and increase our networking events. So I will be more than happy to work in future with all of you and all the presenters within this forum. So thanks again, and hopefully we will have a more sustainable life and healthy life. And I wish you a great fall session, let's say.
Thank you very much.
Thank you.
Thanks,
Have a good day.
Cheers.
Thank you very much.
Bye-bye.
Ayşegül.
Bye-bye.
Thanks a lot.